Before we begin, I would like to emphasize that this podcast is separate from my teachings and work at Dell Seton Medical Center. Any discussions we have on this podcast is for entertainment purposes only and in no way connected to Dell Seton Medical Center. Welcome everyone to another interesting episode of Life of Flow. My name is Lucas Ferrer and
Miguel Montero Baker.
And today we have the pleasure of bringing to the show one of my favorite people in the world. I call him the Mad Greek.
I call him the Greek cowboy.
Yeah. And we have Dr. Dimitrios Miserlis, assistant professor of vascular surgery at UT Dell and mad AI scientist trying to basically take away our jobs with artificial intelligence and robotics, and we'll have an interesting conversation on those topics, and hopefully he doesn't take our job.
Two vascular surgeons walk into a bar and come out with a podcast. We are talking everything vascular and not. Welcome to the Life of Flow podcast.
Welcome everyone to another episode of the Life of Flow podcast. Today we have one of my favorite people in the world, someone I work with. Oh,
you're so nice to say that about me. Man, Lucas, we've been doing this for now 20K shows, and that's the first time you ever said something nice.
Well,
thank you.
Two of my favorite people, actually, so this is super fun.
It was not about me.
No, but I work with the legendary and great Dr. Dimitrios Miserlis. He is one of my colleagues here in Austin. And he is an expert in two things that are of great interest to us and to probably our audience, which one is vascular surgery. He is a professor of vascular surgery at Dell Seton Medical Center. Assistant professor. And he does very, very interesting research in a gamut of topics. One of them is artificial intelligence and its application to vascular disease and many other pathologies. So it is a great pleasure to introduce Dr. Dimitrios Miserlis.
Thank you very much for your kind words. I really appreciate it to be here with you guys today.
Yeah.
I think there is a lot of interest in the applications of artificial intelligence in our field, and has been a lot of talk lately. It's been a hot topic in the media about a lot of different things like ChatGPT and the effect in our in the medical field, in education.
Tell us your opinion on ChatGPT, Dimitrios.
I have no opinion on it. It is not my field of expertise. Although I think it is based on a transformer neural network, but it's not the topic for today.
So Dimitrios, where did you grow up?
I grew up in a very beautiful place called Delphi, Greece. It's in the mainland of Greece. Most people know it based on its historical significance, the Oracle of Delphi. So for those who don't have this exposure, the story goes in the Oracle of Delphi, there was a council, and the council had this a person who could foresee the future. So kings and people of significance in the ancient world would go there and take her opinion on what might happen with their next expedition, usually a war.
Yeah.
So that was that's where I was born and raised. I come from a family of people of interest and focus on education, intellect, sciences, and knowledge. And so that led me through a lot of different coincidences in life or not to be here today.
Yeah. How did you get here? Like tell us a little bit about your journey. How did you end up in Austin, Texas?
I think it all started when in med school I started doing research inspired by people that they had done something significant in their lives, like getting involved in developing a new medication, or some of the guys that actually designed neural networks, brain neural networks, or discovered a new genetic system, kind of like transposons.
Mm-hmm.
So they said, we see your passion and your interest to help and develop something and create. So I got involved into research. I got funded. I ended up in the U.S. building things in relation to tissue remodeling, oxidative stress, senescence, new biomedical devices, and primordial software, which today we would call it AI, I guess. And then moving into my surgical training, I ended up in Texas, where I met you. And then I think we synchronized there.
Yeah. Where did you do your residency?
In Nebraska, in the University of Nebraska.
So how did you come across with this guy? What were you doing?
So in Nebraska, a very robust research center, medical center, cardiovascular, transplant. They, based on my training, my mentors spoke with the team in University of Texas San Antonio when I first started. They wanted to build a research program and build more advanced stuff around biomedical technologies on our field, the cardiovascular field. I ended up in Texas for that particular reason. And then Lucas got hired there the first year to build advanced lymph salvage. So somewhere along these lines, we were able to blend our ideas and coming from different perspectives to try to build something together.
Do you remember the first case we did together? I don't, but we've done a bunch.
I think the first case we did together was an infected thoracoabdominal aneurysm.
Yeah, sounds about right.
Sounds about right. And moving forward, getting involved in NIH research, when Lucas found a niche and got recruited in Austin, we kept working together. And eventually...
that was my evil plan, to bring Dimitrios with me.
Yes, his evil plan. I would say God had different plans for the both of us. So coming here, it was a very beautiful thing for the both of us. I think coming along and seeing how things are progressing. So that was
despite this very clear bromance going on here, are you happy? Are you professionally happy? And have you found ways in which a program that potentially isn't a huge academic mecca, does it offer some opportunities that you found interesting to develop some of your projects?
I fundamentally believe a place is and its success and how happy you are is based on the people you work with. And because I met very good scientists, very good people, both my collaborators, the leadership, and the people that I work with, both at the university and at our Ascension system, I see this as a very fertile environment, and that's why I'm very happy. And the people I work with, they're very supportive, like Lucas and my partners. I am happy. Lucas knows that I have always been extremely passionate, and I spend most of my time in the hospital and outside the hospital building things. And I think that's what drives me is to create and leave a legacy back to help our patients outside what our today's technology allows us to do.
One of the biggest challenges I've recognized in my career for people like yourself, that the term that's been coined here lately is surgeon investigator or surgeon researcher, is the hospital understanding your needs and the hospital moving away from the RVU model to evaluate you in other ways, and specifically staffing becomes a problem, because in order to be very successful at what you need to do, you certainly need to have some people around you that are helping you, that are, postdocs, people, assistants, research coordinators, even administrative staff. Doing NIH grants and getting submissions and getting non-dilutional support, that's a lot of work, and it's hard for a one-man show. So have you found the institution backing you up in that particular sense from a assets standpoint?
I think the solution comes from what you said. It's not a one-man show. So it is difficult to build two parallel careers, a clinical career and a research career. However, that model is not something I developed. My mentors developed before me. You need to build a balance between the two, and based on how much effort, talent, and how much well organized and integrated is the network of people you work with, the better things will go forward. I think both the hospital and the university has a great interest because they see that the future is into building new things. You can be an end user, so you take what the industry and the current research and development has already produced, or you can be a creator. So I think people embrace that. They want that. They want to develop something new. And this gives the solutions that our society needs right now. Being able to do precision medicine, being able to include people and communities in need and give them a solution. Our system is very expensive. And the reason is because, to build a new medication, to build new technology, it requires a lot of time. It requires a lot of novel technology. It's extremely expensive. But I think through technology, we can have solutions to help a lot of people. And I'll give you an example. First of all, I feel strongly that my success is not solely because of my skills and what God gave me, is also because of the people that God put around me. It's the network I'm building. Smart people and scientists in my field as clinicians, basic scientists, engineers, all of this network I have built and maintain an integration with my field is what drives all of this. And speaking about the topic of today's discussion, artificial intelligence. Artificial intelligence means a lot of different things for a lot of different people. And I think I love this discussion today because let's put things into perspective. Forever, science has discretized reality. So we break reality apart into little pieces so we can study and understand them. So let's try to do the same thing with AI. Okay. I think medicine is very complicated. The topics, the problems that we have to deal are not man-made, they're nature-made. And thus they're almost close to possible to solve 100%. So we approximate solutions. The notion of artificial intelligence, the idea, is fundamentally based on us, humans. So you have a system that can reproduce what we do. And on mathematical principles, or at least it started there, that actually they've been around for 2 centuries. So most of the original AI systems are based on algorithms that they were around since the 1800s. I think if you want to move to probably what we call in the modern world or our today's world AI would be what happened in the 50s, 1950s. Dr. Turing put a definition down to it. And so basically, if you want to think about it this way, a smart system or an artificial intelligence, an intelligent system is when you have an observer and then you have behind a curtain a human being and a system, a mechanical system, and you ask a question and you cannot discriminate who gave the answer, the human being or the machine, then that system has passed the Turing test, that it's an artificial intelligence system.
Haven't we passed that already?
Oh, by far. Yeah. And I said, this definition was given in the 50s. So from the 50s to today, probably, things have changed a lot. That's why AI today means a lot of different things to a lot of different people. And to take it a step further, we all, from our childhood till now, have used separate things that they are AI-based. We just didn't think about it. For example,
but I'm sorry, let's back up real quick and for our audience, what is the Turing test? Because Alan Turing, British mathematician, brilliant guy, horribly prosecuted, by the way. I don't know if you guys know this story. No. Oh, no, terrible. 1950s, openly homosexual.
Oh, really?
Prosecuted for his sexuality, chemically castrated.
Where?
And commit suicide. And this is
in
Alan
Britain
Turing
or?
in Great Britain. So incredibly sad story, but clearly,
let's not get chemically castrated, please.
No, but it just shows, how much we've we've progressed in such little time, but then also how much did this guy really, like, how advanced was he to the field that we now have? So the Turing test is I'll let you expand on that.
So basically, you know, what Turing tried to do is to say, hey, how do we define that a machine, because that's where it all starts, how a machine can do what you and I can do. And that comes to the next step, you know, say, okay, what are the fundamental disciplines of AI, of artificial intelligence? One of it would be natural NLP, natural language processing. For example, you know, you dictate in your phone to basically understand language and produce it. The other would be computer vision, okay, to be able to understand images the same way you and I do. Robotics, to manipulate things the same way you and I do. Knowledge representation, so systems that they acquire knowledge, and automated reasoning. So use that knowledge to be able to come up with some answers. Or machine learning, that is so being discussed lately so much. But things, these are just crude, gross definitions, just like I said, so we can start understanding. The mathematics, the software, the machines, and everything else involved, you know, it's just today it evolves in so many different branches that's kind of hard to put in one box. So Turing tried to give the first idea. I think subsequently you will see that basically the first AIs were built for computer gaming. Coming forward in the 90s, you know, the world chess competition between Kasparov and Tipu and all that.
Yep.
And all of these things. But AI is integrated so much in our lives. Your spam filter in your email, your voice dictation in the hospital. And moving forward today, the things that we are building and what we're doing is, for example, diagnostic systems. So the work that a radiologist is, obviously, I don't want to oversimplify the work of a radiologist, but reading an X-ray or a CAT scan. I think today, without a doubt, we've built AI systems that they can do that much faster and probably with accuracy that would be qualifying for medical use.
Yeah. It's probably going to be better than a human, I imagine, at diagnostics.
So when you talk about being better than human, you have to define. And to define that, we need, so our science...
Isn't it simple? Sensitivity, specificity?
I don't think so.
No, okay.
And I'll tell you why. One of the biggest problems that we have with automatic systems and devices is the same problems you see every day. Like, I have an idea, but how do I put that idea down in code or in a hardware piece to do what I want to do? It's hard, number one. Okay. Number two, the problem that machines have is that we give them information and they evolve, but the information we have are not complete, are not perfect. So they will have the same shortcomings and limitations, and sometimes even more. Because one fundamental problem that AI has, and I don't know, pretty sure a lot of people are working on solving it now, is imagination.
Yeah.
AI does not have imagination. You can approximate it.
Well, we don't know what imagination is.
Exactly. Comes back to the first problem I described. How would you put
consciousness?
How would you put that down in mathematical algorithms or computer programming?
I mean, you would have, I guess, the same way that, I don't know anything about this, right? But from the little bit of information I know, the same way they worked on ChatGPT, they just have a human in the back end kind of correcting it and guiding it along. So you have expert radiologists. So let's take away the radiologist job first. You have expert radiologists telling that, no, this is not this is not ulcerative colitis, it's a tumor. Or this is not whatever, like a aortic occlusion, or this is not a rupture aneurysm, this is an inflammatory aneurysm, or something like that. I don't know.
I think there are people that are much more qualified to give you that answer, but I think the answer is very simple. There are different, for lack of a better word, it's called ML tribes, machine learning tribes, or models. Okay.
Yeah.
So in a very simplistic way, there is unsupervised learning where you give a machine ins and outs. So you give them an input, the machine has the output, and then adapts and learns. It's unsupervised, where you give them the input, but it has no output. Try to deduct an output.
Yeah.
And there is experience-based reinforcement learning, where you give, you try it out, you get some feedback, you try it out again. There are multiple different things. So by trial and error, or what you just described, you still don't solve the fundamental problem of imagination. I'm sure we're going to get there.
Do you need imagination?
I think you do.
Why?
Go back and think about the history of medicine.
Yeah.
Outside the very robust and systematic research that we do, a lot of things happen by accident or because someone imagined it.
It's called serendipity.
a lot of the problems I had to solve, sometimes either I solved them when I was sleeping. I woke up with the idea, or I was sitting somewhere drinking a Greek drink, looking at the beautiful sea of sand.
Raki.
And, that idea just, comes up.
Yeah.
So imagination is important. Obviously, there has to be a technical term for it, and there has to be, a more mathematical way of explaining it.
Miguel, can you look up in your computer, like the discovery of the concept of zero, the number zero? If I remember correctly, I might be completely wrong. Look it up. If I remember correctly, it's this guy from India, and he was, I don't know, but he was meditating, and in his meditation, he came up with the concept of zero, nothing. Before he came up with it. So, there is an intangible aspect to imagination. And come on, leave something for humans. Leave something for us. Like, why do you need the imagination? We can guide the AI through our intrinsic imagination, no?
I think that's a completely separate issue. It's a different thing when you're trying to discuss the technical aspect of something, how to build something, and it's a different thing to discuss its purpose.
Yeah.
Which one has to come first? I mean, if you talk about our modern society, before you invent something that does not need to be invented, you better find a purpose for it.
Yeah.
I think we do have a purpose for AI. Obviously, you see every day in our work how difficult it is. You see that even the most experienced people, and I mean, there's enough experts on this table to say that no matter how much experience and knowledge you have, there's still problems we can't solve, and we cannot guarantee the outcome. Partially, the problem is the limitations of the technology we have. Partially, it is because we don't know everything in medicine. We're still discovering a lot of things. And so to have an extra tool, you can see AI as a tool, but an intelligent tool. We can probably fill in the gaps, help us fill in the gaps.
What do you think is the first part of, let's say, vascular/endovascular pathology that is going, if you had an oracle, if you went back home, what part of vascular or endovascular pathology in the cath lab, in the OR, is going to get disrupted by AI?
It already is. I mean, first, it's already happening.
So,
how?
There's multiple companies out there with FDA algorithms that already are AI-based.
Are you using it?
No, you're using them. You just don't know. The way that they're implied right now is there's institutional licenses. These licenses, what they do is there's always going to be a radiology reading, but the reality is that radiologist that's reading 100 studies every 4 hours or so.
Yeah.
How does he know that one read needs to go up the top of the list, because that one read has a penumbra of ischemia that probably requires stroke management? And so if he's just reading as they come in, there's absolutely no way he would know that patient 001.
Yeah, but that's not us. I'm talking about us.
It is us, because you're now called.
Yeah, I know. But in your hands, like in my hands, or like in the cath lab, in the OR, what's going to change?
I think looking back at the systems that I have building, and outside the university, I have a lot of activity, and I interact with a lot of people that they have been in this business. Moving back several years, I can tell you that what you described right now is basically what we have been using, and you're correct, he has been using it, he just doesn't know. One of it is, for example, the initial filtering of the images that the radiologists use, obviously with the limitations of the FDA that needs to be supervised, etc. The other thing is, for example, when we do angiograms, the crisp imaging that we get today with less radiation, that's also part of an AI system, or the 3D modeling we do for aortic reconstructions. These systems are smart systems based on this type of software and algorithms. It comes into our practice and you don't even know it. Again, think about your spam filters in your email, right? Or other things.
They're not that good.
Well, that's because they're learning. Yeah. And if there are advanced cybersecurity AI systems right now, but obviously, with certain limitations and applications, it's good to be cautious when you roll out a new technology and how things are. But look around you, self-driving cars, all of these things. Going back to our medical field and the systems that I am building and I'm interested in, I think computer vision and analyzing, getting the images and getting a diagnostic or a prognostic, idea is the first thing that we will see. And we're already seeing it introduced slowly. The next step is robotics. And I think the robotic systems, the main problem is, as you have seen, introduced robotic systems from the 90s into general surgery, but not intelligent systems. We have certain hardware limitations, mainly limited at the time because of the technology of that era. I think we're transitioning to a new era, working with soft robotic systems and other smart material. I feel that will be the next step, and I think moving forward in our practice, when you and I are going to be close to retirement, this is what is going to become the next best thing. Why is this important?
What is going to become the soft robotics?
Probably robotic systems that they will automate or at least put an extra hand for help. Assistive surgical systems, for example, and that's what I was getting to. Think about why is this technology important? Because I feel it helps us fill the gaps into inclusion medicine.
What is inclusion medicine?
For example, why you and I, coming back from different backgrounds, races, have different response to medications or devices. We don't have the capacity to study it as easy because the amount of data is difficult. The outreach to collect the data is difficult. Or, for example, why if someone ruptures an aneurysm right now here, you're 5 minutes from the hospital, you can probably save his life with 50% mortality. But if someone ruptures an aneurysm in the middle of a battlefield in Afghanistan or at the border where people don't have the same resources we do, what are they going to do? So a robotic system that can do the initial steps to control the bleeding could be life-saving. Mm-hmm. And that could bridge the gap into all of these issues with healthcare and disparities in healthcare. So you see how technology blends into our unsolved problems today, into our modern way of life, and how it helps all humanity. There are so many applications. Predicting just how many things we do, how many times we do things, and we don't know 100% what would be the outcome. What if you could quantify that? What if I could tell you I can analyze 1 million times more data than you and I can possibly do within a minute and get a better idea of what we're going to do will actually help us?
That feels like less control.
Less control, not necessarily. Less control into the things that we have. We have to let go from the role we have now and move to the next step. We have to leave this to the technology and move to the next challenge as human beings.
Do we have to have a chip implanted in our brain to understand? Because at some point we need to understand. Don't we need to understand what's going on? One of the super interesting things that was kind of scary is I was listening to, I think it was the Lex Friedman podcast, and he's interviewing this researcher in AI, and he gives a task to whatever program he's running, and the algorithm does the task, but they don't know how it's going to do it. Their research, from what I limitedly understood, is to go back and look into how it did it to understand. So this thing or these things, these entities are doing these complicated tasks, and we have no idea how they're doing it. So you're saying, okay, you are going to give this algorithm, let's call it an entity, all this patient data, and it's going to come up with a solution. So you say we're going to have the same problems we have now. We have a patient with limited resources, with limited education, that comes in with a complex problem, limb salvage problem, and we're going to call it Hal. You remember, who Hal is, Dimitrios? Yeah. We're going to go to Hal. You're going to say, hey, Hal, what should I do?
Who's Hal?
Hal is Space Odyssey, the AI in Space Odyssey that kills them all.
I personally like Ex Machina much better. Yeah. Phenomenal movie.
I don't know why everybody's thought when you talk about novel technologies goes immediately to the worst case scenario.
It's called the atomic bomb, Dimitrios.
Okay. It's called human nature.
It's called human nature.
Going back to
robot.
Let me finish.
Robot
and you're
nature.
going to say, hey, Hal, what should I do for this leg? And Hal says, well, you should do, and it's your approach, and you should do excisional atherectomy with angioplasty, and you should use, based on the patient's genetic, this drug-coated balloon because it works better.
Should be.
And
I hope so.
Yeah, and that sounds great,
Mm-hmm.
but you don't understand at all why. The why. And I think I love understanding the why, because then that leads me to solve the next problem.
Why wouldn't you? You would just ask Carl.
Because you won't comprehend the magnitude. It's like I read somewhere that there is a black hole somewhere that spins, and because it spins, it creates a certain amount of energy, and it was like something to the 10th to the 16th, something to the 16th joules. And I can't comprehend that number. That is a number that I can rationally read it, but I don't understand what the hell that means. And I'm not going to understand what the hell it means when Hal tells me to do this algorithm. So how will I be able to understand to solve the next problem? Because if not, I'll be driving blind.
I hope we hopefully soon get Adderall as one of the people that support this program, because the way you spun into the black hole of numbers it
makes total sense in my brain.
Beautiful. But here's let's bring it back.
Let him answer the question.
There's not a question.
Do I need to have a chimp implanted in my brain to understand how?
I'm going to bring it down to the fact that you were impressed by the fact that they give a machine data. They don't know how it solves the problem. Well, that goes back to unsupervised learning, deep learning, and other things. Basically, you give a machine that tries multiple different things. It evolves, it adapts, and finds a solution, which for you and I would take a long time. But there are other advantages to our entity as human beings. Now, as far as the why, I don't think AI cares about the why. We're building something to find a solution. It's an assistive system. It helps you solve a problem. The why is more for humans, not so much for the machines. We set the boundaries. Will an AI system ever cross those boundaries? Well, it depends. It's a complicated
That's
issue.
Comforting.
It's a complicated issue that I think at this point we have so many problems to fix before we get to that. But it's not my field of expertise. It's more of a philosophical question.
You're Greek. Aren't you like an expert in that by birth? Philosophy?
Well, Greeks also were doing mathematics. So, let's get to that.
Yeah.
When I first did when I wrote my first code, when I was around 12 years old, building a game. It was a game. I built a game for my mom as a gift. And so I never thought, the why was very simple for me. I had no money, so I had to do something for my mother and show her I love her, simple as such. Yeah. Now, when moving forward in the future, all I think when I build and I help bring together people that are smarter than me, they have, diverse complementary expertise, is how to solve a problem and how to leave back a legacy to help people that suffer today, that we don't have the capacity to help them out. The why is very simple in my mind. How that why will get interpreted moving forward from the technology per se, because it's an intelligent technology, I do not know. Nobody does. But the good thing, then at this point, I would say it's good that AI doesn't have imagination. So,
yeah.
So we're about 10 minutes away. I feel like we could talk for hours about this. This is incredibly passionate because it really, it's a fine line between science and philosophy, right? There's so many philosophical points that you have to, but let's focus on what you, as we kind of land the conversation, and then we'll have a part B, C, and D, because I think the Greek scientist, philosopher,
the
mathematician should be a must every other show.
Yeah.
But what should we be doing? Okay, what as scientists, as physicians, what should we be doing other than just be scared to death about a tool like Lucas is apparently scared of authoritarian machines that are going to help him take care of patients better because they're going to know more than you.
Yeah.
Love it or hate it.
Yeah.
But what should we be doing to progress this in the right direction?
I think outside the very elusive idea of science that we kind of like discuss right here, it's not elusive. These things are very specific, discrete mathematical models, software, hardware. Is a science. But we as surgeons and we as people understand certain things. And I think what drives us all is our oath to help other people. So what we should be doing is think, what is the problem that we cannot solve, but will have an impact to help a lot of people? Number one. Number two, one thing that even in 2023, in a very impressive, to me, it's at least very impressive, communicate. We don't communicate well. Even now in 2023, scientists across disciplines do not communicate well. And that's one of the main things that hinders the progress of science towards solutions for the betterment of humanity. And that's been around for a long time. How do we solve it? I guess I don't know. Try to communicate better. I think now with the technology that we have in our hands to transfer information across the world instantly, and as people learn to respect each other, and we all see that we have a common goal in the end of the day, to survive, to improve our lives, to live a better tomorrow for our children. I think this is what should guide us. We all work day and night for solutions. If you keep these things in mind, communication, and the fundamental goal for every single human being I have met in my life is a better future, is to help the people that they care for. I think that's all it takes.
Yeah.
I love the idea of, imagine if you can, to build upon your thought, because I think it's very important. There's all these siloed scientists around the world working on different problems, but at the end of the day, it's all chemistry, right? I mean, everything's made from the same basic particles, and it would be ignorant to believe that solutions for other sciences wouldn't apply to realities on a daily basis for our care and our patient algorithms. And interestingly enough, we've gone to the point that we do conferences to bring different specialties together to just compare and contrast. And I'll give you an example of that. In Houston, we run this meeting. Well, we run now, but there is this meeting called Pumps and Pipes. And what it's about is you bring engineers.
I know that meeting.
It's a great meeting. It's awesome. Yeah. So you bring physicians that work in the cardiovascular arena. Yeah. And you bring engineers from the oil and gas. Oh. And they literally get on the podium and they talk about problems. And so they'll say something like, well, we have this sludge that builds on the pipelines and eventually it's a problem. And that's actually how the green filter came about.
Exactly.
They had filters for, petroleum conduits that he was like, oh, wait, we should do that for IVC filters. Huh. And so, but it took a human effort to put those two together. Yeah. And an intellectual exercise to add and say, hey, you and I should talk about this because it makes sense and what can be applied. Well, think about integrating the entire internet and the entire global compendium of knowledge and that these large language models can literally dig through all this, you know, crawl through the internet and get you answers in seconds. I think that's brilliant. What I'm afraid of is that control of that much information can be also a little bit dangerous, and there's going to be an interest on financial gain. So what's going to happen, and what's happening now with, for example, ChatGPT or BD from, Bard, you know, the Google large language model AI assistant, is that a lot of these companies are closing their websites to that knowledge so that these entities will not crawl. So you can't get, you know, Reddit, for example, they don't want to share anything that's on Reddit. They want to monetize it. So if ChatGPT wants to crawl through my information, you're going to have to pay for every time that crawler seeks through. And there's going to be a financial gain monetization. But maybe there's a way in which you can gain access to some like scientific database with a certain payment that would help you be like, listen, there's this guy in Okinawa who is working on how to break bonds, and you're doing this thing here with this drug-eluting stent, and you're creating this bond. That thing that guy's doing could potentially solve this problem. Pick up the phone and call that guy now.
That kind of exists as a model. I mean, I'm very proud about our country because it's called NIH.
Are we talking about Greece or the United States of America?
America.
I'm proud for both nations. And you know, as Greek, thousands of years loaded with
beauty,
love of knowledge. I can say that, you know, in our country today, in the United States, NIH is making a great effort to provide free all of this information. Everything that I do in my lab with my collaborators is uploaded. Everybody has access to it, and you can get. Now, that being said, hotspot, you were on the spot on this problem, compartmentalizing knowledge and science secondary to monetary, legal, patenting, and other things. Man-made problems, of course. We restrict our capacity to solve problems. But, you know, not everybody thinks like you and I. And thus, I think as scientists, we owe to the world. Because you, as a vascular surgeon, me as a vascular surgeon, but translational scientist, we all can communicate better with the people that have similar expertise and similar challenges in other countries in the world. And it's easier for us to come together and solve these problems than the big conglomerate companies or other people. I feel we have an easier way of communicating the flow of information. We can make the first step, and I hope that people will follow. I think this is something that has been happening for many years. But again, communication, coming back to the question, communication is one thing we should be doing, and working on a target that will help us solve the problems we see every day, and we keep inferencing through different solutions. But at this point, we have to throw in assistive technologies, AI-based assistive technologies, or work on financing, funding new experiments, new technologies on the hardware end, as well as the software end. You know, all of these take a lot of time. But in the beginning, like my ancestors were saying, is communication.
Yeah.
There's a beauty and there's a comfort and a commodity in being plugged into a system that has years of development in science and medicine and clinical care. But there's also an excitement and a rush in many ways to be part of a program that doesn't necessarily have all this. And I commend you both on working together and taking a leap of faith in a way into a program that may have not been developed to the point that you would all love to see it, but that has the alternative of doing it. And the beauty about having potential is that you can both shape it into what you can, you want. And so I think you have a very beautiful opportunity. I hope the bromance continues for many years.
Oh, it will.
And I'll throw this in there that, when you guys have kind of ironed out all the kinks, then let me know and I'll come and work with you guys. I don't want to be lifting all the heavy weight. I've done that many times in my life. But anyway, Señor Dimitrio, thank you very much. This has been phenomenal. You're a rock star. I hope the world listens to you more, and I hope that this platform helps you find even more viewers, listeners, supporters for your research and for your thought process. For us at The Life of Flow, it's an honor to have you, and we hope to have you again here shortly.
It's been delightful to have both of you here. I think I should say at this point that I feel both Dr. Ferrer and his mentor, we're sitting across the table, have been very inspiring. We are all driven by several things. One of the things that drives me is to see this connection and to see this passion and fire.
You said it at the beginning, that the human connection, a good job is a job where you love the people you work with.
You're both experts, and you are both honorable scientists and people. And I'm very excited to be involved with you. And hopefully everything we do will help our patients and help build a better future.
I promise I'll dress up next time.
No.
He definitely made us look. Look at him. He looks like a Pierre Balmain model here.
A what? All right, cut.